welcome Julian and Nico. They're here today to talk to us about using Thompson sampling and self-learning models to improve targeted advertising. So help me welcome them.
All right, cool. Thanks for the introduction. So I made a quick overview of what we're going to talk about today. First of all, a very brief company introduction, probably the most boring part, but we'll spend about 1 minute about that. Then to briefly set the stage is to talk a little bit about personalization and why it matters. Then I'm going to focus a little bit about the car manufacturer's case study. This introduction part will take about 10 minutes, and then we're going to dive into the most interesting parts. Will Nico take over? It's about Thompson sampling, multivariate Bayesian, and the results about that. So the large part of the talk will be about the statistics itself. Finally, we'll talk a little bit about the results of what we did, and briefly touch upon some future research and improvements. And hopefully we'll still have some time left for questions. So really quickly, company introduction, and it's not a promotional talk here, but we are here from Group M. We are also sponsoring this event. And basically, we are in the media industry. So Group M is basically an umbrella organization, and beneath us is Mindshare, Media Comessence, Wavemaker, and the Netherlands Greenhouse. I don't know if some of the people may know Greenhouse here, because I think we've also been quite present here in the past here, but we are rebranding as of next year largely into Group M. So what we do is largely media investment, media strategy, but we also have quite a strong data science and data technology presence. We manage 60 billion spent globally. Wow, a lot of money, but it's not our money that we make. It's the money of clients that we spend, so it's not our income. We have 41,000 employees globally, and we're active in 80 markets. So we're here from the Netherlands representing that. So first thing first, let's talk a little bit very briefly about personalization. I think it's for many people here, you probably read something about it in the news, especially with all the developments within GDPR, privacy, etc., that it's becoming more and more relevant. And a little bit about the client's challenge before we dive into what we actually did for the client. I made one slide about this, but personalization is, I think, becoming more and more important in our industry, in the advertisement industry. Consumers expect brands to demonstrate that they know them on a personal level, and it's just some very brief statistics here, but we see that when marketeers are able to leverage personalization, they see actually, on average, about a 20% in sales when they use it in the right way. Shoppers are also more likely to buy something from a company that offers personalized experiences. And consumers, a large set of consumers, they have recommended or chosen or paid for brands that actually offer them personalized experiences. So it's actually growing right now, and people are really expecting this. However, when we look at our industry, we see that many companies are really not leveraging that opportunity right now. And I know this chart is not like something that's very backed up by data. It's very average, but what we see is that what we want to do is we want to run as most effective campaigns that we can for our advertisers as possible. So all the marketing budgets that we spend for advertisers, we want to get the best ROI of every euro we spend for them. And obviously, when we can target our consumers with the best product and the best offers that we have, then we achieve that. But what we're seeing right now that most companies are not doing it in the right way. So the most targeting that they use often is like social demographics. So they're targeting maybe personalizing based on, hey, who's male, who's female. Sometimes maybe they're targeting addressing a person by its name. But obviously we can go much further than that. But when we go further than that, it requires some more advanced things. You have to think about technology, but also algorithms, etc. And a lot of data is being involved. And most companies, they don't have the capabilities to do that at scale. And actually, it's quite a big opportunity that we're in. It's booming right now, and that's why we're investing in this. And then one more slide. So why is it not easy? And obviously, this doesn't cover all, but it's just to give you like a brief introduction. First of all, data foundation. So when you want to personalize, you need a 360-degree view of your customer. That requires often that you need to integrate quite some different data sources to get that 360-degree view of your customer. So often that data is siloed in either CRM databases, you need qualitative research, you have behavioral data, you have market data, so you need a lot of data that you need to integrate to get a good idea about what your customer prefers. Then when you think about personalization, you can have a strategy, hey, I have a one-size-fits-all, I reach all the people with one ad, or you think, okay, I'm gonna deliver a specific ad for one specific person. But when you even are achieving that, then you also need digital asset management that follows that, meaning that you have to have individual designs that meet those needs of all these individual customers. This can also be quite challenging and also costly. Then thirdly, I think you also require technology to achieve that. First of all, to manage all those different data sources. So thinking about data warehouse and data lakes or customer data platforms, DMPs and legacy, you need supporting data to have that, and also to deliver those personalized experiences via dynamic content optimization platforms. And fourthly, and this is the focus of the talk, you need an intelligent decisioning mechanism or algorithm to also decide, okay, what I'm going to show to what customer at what moment or what time, and to have some logic behind that and not do that based on expert judgment. So the common challenges we see with this is that, and I think I touched upon those already a little bit, is that the data required for effective personalization is often trapped in like lots of silos. We work with quite some large advertisements, and we always see that we want to have one central view of the customer. Most advertisers, they don't have the data in one central room. They have it in a lot of different places. Then the decisioning logic is often done based on expert judgment, and even if they want to build an algorithm, or then usually they don't have the capability in-house to do it themselves, so they need to go to third parties or they come to us. Then what I mentioned, the design part, okay, so nice that you are ambitioning to start with personalization, but it also means that you have to develop lots of different assets, which can be costly. And also the experimentation programs to find out if it's working or not is also going to be quite intensive. And lastly, the technology part often is not even available, or they are like underestimated requirements to even get those experimentation programs running, and what technology requirements are associated with that, and they don't have the investment ready to do that, or they don't have the technology yet. So having said that, I want to make a brief jump to the car manufacturer's case study, just to, that you guys have an idea for in case you didn't have, so what's associated with this. So what we had was a car manufacturer called X. So these are images of an Aston Martin. So it's not Aston Martin that we did it, but I found these nice images on Google which look nice and they fit right, really cool on the slide. So there's that. And they have quite a large range of car models, and they want to deliver that to a diverse set of customers on the market. So again, maybe Aston Martin would not be the best example here, because most people that buy that car are rich, right? So Volkswagen would be better, but I didn't find nice pictures. But anyway, to attract these new customers where they had no previous interactions with, they had quite a large budget available for that to reach those customers. And the way they did that is with display advertisement. I'm not going to go into detail. I don't know how many marketeers are in this room, but display advertisement are those annoying banners that you see either on the web or your mobile when you're scrolling and you see these banners popping up. That's what they use for that. This client also, and shockingly, many clients don't have, they had no understanding of the distinguishing characteristics of preference or attitudes of customers that drive unique purchase behavior. So what do I mean by that? Obviously, also sitting here, we don't have one group of people. People here have different preferences. We have males, females, but we have different jobs, we have different attitudes, different preferences. One likes this, one likes that. So people can be segmented in groups, and they had basically no idea about all these different models. And you would expect the factory producer's model was like, okay, we're going to produce this and then this model because this fits this one customer, this and this and that. But they had no idea, and this is something we see with many customers. So what they ask is, okay, so we're going to want to get a better ROI of our marketing investment. So we help them with the question, so how can we advertise the right car model with the right message to the right customer at scale? So what they had now as a legacy setup, or the current setup, was basically they optimized towards showing the best performing car model to one large audience. And with performing here, I mean that was calculated in, okay, how many clicks they got on an ad. So, but now they were focusing on one large audience. So there are a couple of challenges here. But first of all, the way they did it now was for an A/B testing setup. So in this example here, you see 3 cars. They had more cars, but it's just an example. And the way they did that is that they rotated these 3 cars equally for a certain amount of time until they had enough data points to say, okay, one car performs better than the other car, calculated in the amount of impressions showed and the amount of clicks they got out of one of the cars. So if one car got more clicks than the others, compared to the impressions, okay, this car is apparently more likable than the other ones. There are a couple of challenges with that. The first one, the most important one, is obviously, I think, that there is a large opportunity cost here, because let's say that one of these cars would indeed perform much better than the other ones, then we have had quite a long time that we have shown underperforming assets to our large audience in the time we could have shown better cars, higher performing assets. The second challenge we have in this part is that they're assuming that there is just one audience and that people don't have specific or different traits or unique characters of their behavior that make them prefer different models. They just have one big audience. And the third part here is that they don't think about they assume that the only differentiator that drives performance is the model itself, but not the way we present the model to our audience. Because, for example, even though in this audience some people may like the same model, the way you maybe find that model appealing was maybe I showed to you the USPs of a car being safe or a car having like boot space, or on the other hand, some person may like that the car has like a fuel efficiency or is electric or is energy friendly in these terms saying. So it's also important, and that's like key in marketing, obviously. How do we sell our product? It's not okay, I like this product. No, marketing is all about emotions. How do we sell the product? So what we proposed, and this slide may be a little bit difficult to understand, but I'll take you through it. So what we propose is different. So we wanted to optimize showing the best performing concept, and concept meaning concept, a variation of a car, the variation of a banner. I'm talking like showing emotions in a banner. So how are we going to present the car? That's a variation of the best performing car model, of the model, to the right audience. So you see we also defined different sets of audiences here for the people. So in this way, if we do it in that way, it's going to be a different design, and there is a couple of things that we want to touch upon. So like I said, like first of all, the thing is, I gave you the example of that we feel like what was missing was the differentiator on how are we presenting the car. And I gave you the example like, hey, let's say somebody here likes a BMW. One person may like the BMW, okay, but why do you like it? And why is it appealing that you are present to it? Some people just like the looks of it, and some people say, okay, I like a BMW 5 Series. Because this car has certain technology, and another person, oh yeah, but I also like the 5 Series, but I value it for a different purpose. So we found that differentiator in it is very important. Second of all, the problem that we're going to see here, and that's very important to consider, in the slide before you saw we had 3 different models, and that means that we have 3 variations to test against each other. And I already said there are already opportunity costs arising there when we have 3 models, because if you show one model is performing much better than the other, then we have like, let's say 66% that's like underperforming. Now in this case, we already see like we have one model on the top, second model below, and we made 3 variations of that model. So what happens here if one of these models is underperforming or much better performing, the opportunity costs are going to be even higher here. So we have to think of, okay, how we're going to fix that and how we're going to do that efficiently. So we want to learn in between. So we want to learn when we run our advertisement. Also, when we learn that one model is performing better than the other, we want to be able to exploit that simultaneously to make sure that we bank, let's call it bank, on those learnings immediately. Yeah, and on the right hand you see, okay, but also was a hypothesis of us, obviously, and that's a very important, hey, we are not targeting one specific audience, no, we're going to think about different audiences because people have different traits. And the most easiest way that you can think about, hey, we have males, females, but there are many ways we can segment audiences, and we'll touch a little bit on that in the next slide. So the final slide before we go into how we did it is very briefly high over approach, summarizing what we did. So first of all, as I mentioned, it's very important to think about the consumer and the different traits that consumers may have. So we leveraged qualitative and quantitative research. Qualitative research meaning we had surveys of research agencies that actually asked people, okay, when you buy a car, so what do you like when you buy a car? What do you value when you buy a car? So is it pricing? Is it security? Is it fuel consumption? Different things that we looked at. So that's what we looked at. And we identified what are the distinguishing characteristics for this brand that drive differences in purchase behavior. Then we also validated that those differentiations in that purchase behavior, these segments of goods that also vary between models of cars. So in that way, we already justifies, okay, we see the segmentation of the audience is important, so the traits are important, also the types of models are important. Then we built a personalization algorithm in between, which Nico will be touching on a little bit. And based on step 1 and 2, we also defined these testing hypotheses based on that research. So the hypothesis could be, hey, we feel that there is, that to achieve performance, also the grouping of the segments of audiences is important. And we feel that the models is a drive. So showing different models is a drive for performance, but also the traits of these groups is important. And finally, I think I'm not going to touch upon that. Obviously, I talked a little bit about technology being important to deliver that to our audiences. Well, the algorithm also needed to connect with our DCO algorithm. DCO is standing for Dynamic Content Optimization. We have in Group M a large technology vendor that offers this for us. We need to make sure that the algorithm automatically sends signals to the technology to be able to deliver those ads at scale. Having given this introduction, hopefully it was understandable for everybody here. I'm going to give everything here to Nico, who will tell a little bit about how we did this with the algorithm, which is actually the focus of the talk of today.
Hey, thank you, Julien. As Julien said, I think Julien sketched sort of the outline of this, the problem which we had with the different issues and the setting which we are working in. And first I'm going to start with sort of the start of the algorithm, which is the Thompson sampling part. Thompson sampling is coming from one specific problem, which is the multi-armed bandit problem, which some of you might have heard about as well. It's sort of a problem between explore and exploit. The question which was raised was, okay, if you have, for example, a few slot machines, and I want to get the best payout out of these slot machines, how do I actually approach this issue? Especially if you want to know which slot machine has the best payout. And you can test this in many different ways. For example, just take test one slot machine each time, and the one which gives you highest payout, you choose that one for eternity. But of course, that's probably not the right approach. Another way which is used a lot in the industry entirely is, for example, A/B testing, which you take like a random sample out of each of these for a certain period of time until you're certain enough that you have the right slot machine. However, this solution is also not optimal, as you then also mentioned earlier. You're losing out on a lot of opportunity where you could have served like a better, you could have chosen a better slot machine in this case. And here I have a little bit of an example about it. For example, at the top you have like A/B testing. You see at the left like you have 3,000 draws in each period, and if you do that in an A/B testing way, then you have 3,000. You have 1,000 for each variant, so A, B, and C. And then at the right you see the number of wins about it, which is of course constant over time in these different periods as well. At the bottom you have an example of Thompson sampling. It's not the exact approach of this, but it's more of an illustrative example where you see that at the beginning you have, again, splitting it in 3 different ways, so 33% for all of these. And then slightly when you get more and more confident, adding more draws to the variant, which is actually performing better already. And as you can see then on the right, that the total number of wins actually increases over time as you get more confident, because you're showing the, in this case, bandit, which is performing better, or you exploiting the bandit, which is performing better and better each time, a little bit more. As you can imagine, this is sort of a risk-reward trade-off, as you, at the one end, want to, exploit the best performing one as much as possible, but at the other end don't want to end up with a losing or a worse performing one. A/B testing, as I said before, solves this trade-off by not taking any information in it entirely at all, and randomly distribute these different draws, so taking at least amount of risk as possible. Thompson sampling solves this issue by actually giving each variant a sample rate which is equal to the probability that specific variant is going to be a winner. And this, on one hand gives a little bit of, it gives each variant a chance to show if they're a winner or not, and on the other hand, slightly increases the percentage of sort of the best performing ones which you're going to show. However, in practicality, you need to estimate this probability of who's going to be a winner as well. In a good way to estimate this probability of who's going to be a winner is by with a Bayesian approach in this case. And you can do this by estimating each different distribution of the probability of a win for each different variant. And in the case that you have like a binary payout, so you have a win or a loss, a good distribution for that in this case is the beta distribution, as it has a really nice property that if you add the using Bayesian law to add new wins and new losses to your information, then you still end up with a beta distribution in this case. In this case, I have here on your right, I have an example where we have the first variant being having 5 wins and 95 losses, and the second one having 10 wins and 90 losses. And with this, on the right, you have these simulated distributions of these two. And as you can see, with this you can also calculate, okay, what is in this case the probability that variant A is going to win over variant B. And in this case, you have for variant A 8% probability to win, and variant B 92% of probability to win. So in this case, you will also show or will choose that variant 98 or 92%. As Thompson sampling is in this case great for minimizing regret or maximizing reward in this case in sort of random solution. However, it also has its limitation. It does not necessarily decrease the time which you need to test until you reach sort of significance, or until you reach the point where you decide, okay, this is the best variant which you want to continuously serve. And if you have like quite a large number of variants, and especially also if you have a very low probability of winning, then this is going to take a lot of time or a lot of tries to actually reach good results. And that's why I also want to touch a little bit about the solution which we used in this case for it, which is Thompson sampling with what we call multivariate Bayesian. So what Julien already explained, we have in this case we had 3 different segments and 2 different models and 4 different concepts. So if you can imagine, then we have 24 different sort of variants in which we wanted to test, which is already quite a large number. And if you scale this even further up in bigger tests, then it's impossible almost to test this with A/B testing. That's why we actually wanted to use sort of our prior knowledge of the things we used in the setup in this model itself. And these prior knowledge are sort of the preference for the model, the preference for the team or the concept, and as finally sort of the similarities across different segments. And we did this by looking at it in 2 different ways. So you have here sort of the action which you want to take. So what are you showing to the people? In this case, it's the model and the concept itself. and the second one is sort of the context. So in this case, it's the segment. It was in this case was 8 segments, but in the context and also in the action, you could do many different things. For example, for the context, it could also be the platform which you're showing, other kinds of characteristics of people as well. Yeah, to incorporate these sort of 3 different concepts for one specific variant, we use so-called hierarchical weighted priors, which use the information of sort of the overarching context for that specific variant into that specific context. However, to have this similarity, we incorporated only the variants or the sort of overarching themes which were, mathematically speaking, one distance away in either the action or in the context. And we'll give a little bit of an example after this. And this way, only variants which actually are sort of close to the original variant which you want to test give actual weight to the prior itself. So for example, in this case, if we had like these 8 different variants where you had 2 different models, 2 different concepts and 2 different segments, then we would look at these different groups, and we'll slowly go through them. So in this case, the first 2 are again the action, and the last one is the context, and the P in this case is sort of the probability that that variant is the probability of that variant having a win in this case. The variants which we have it in 4 different groups in this case, and it's mostly looked at by sort of the distance which they have to the original variant. So in this case, B111. And there's different groups. So then in this case, looking the total group of all variants which have like the same model but a different context, but again the same segment. And the second one, different or all models, but and the same concept, and finally as well the same segment as well. And the last one having sort of 2 distance away, which is ones which is all kinds of models, but a similar concept and a different segment. And finally as well the ones which have similar model, but might have different concept and segment. If you then look at all the different variants, then you can see that all the green ones are the ones which we actually use our prior knowledge for, but the red ones are the ones which we don't use at all in this case. But if you think a little bit about it, some might have a little bit of a more weight than others because they're already closer to the original variant. Also looking at the time, I'll try to speed it up and probably skip past the results as well. What we then do is each of these different groups, we need to give them a sort of a weight as well. And the way how we look at it is, one group can have a certain distance from the specific variant. So this group has also a sort of amount of wins and losses just as the specific variant. And then we look at how far away is that group from the specific variant itself, and then give that specific weight to the prior for that variant. So for example, if a group is very far away, distributional speaking, from that variant, then we don't give them any weight at all or very, very low weight. And if a group is very close to that specific variant, then we give it a much higher weight or rate very heavily. And also have a little bit of example for it. What it does actually is that over time you actually start with the on top situation where both the variant and the group still have a lot of certain uncertainty about it. And in this case as well, you can see that there might be a little bit of a difference between the variant and the group itself, but they're, distribution speaking, still pretty close. However, and this way, the group already gets a lot of weight into the specific variant itself. However, over time, the distribution developed more towards sort of the bottom distribution end, where you can see that the distribution is way smaller. In this case, the group almost doesn't contribute to the specific variant itself anymore, which helps you with sort of it gives you a better start for the specific variant in knowing what kind of distribution this probability would have. I don't know if you I don't know if we have any more time or.
Yeah, you can kind of wrap up.
Okay. Yeah, and also ended up at results. I unfortunately need to skip this probably. Very shortly, we did a first test in this case as well, where we actually saw that there was some uplift. But more interestingly, what we saw that there was a difference in what people actually liked. And also what we saw is that sort of the assumptions which we had that the different groups, so this model and variant, actually held up as well. So models overall which are performing better also over variance itself, and also the variant which was performing overall better is also performing better over the different models in this case. So it was nice to see that sort of our assumptions also met as well, otherwise the entire previous part would have been for nothing. Yes, I will skip all that part, and thank you for your time and your attention, and let me know if you have any questions.
Okay, we have time for a couple questions. Yeah.
So one of the things you mentioned was the limitations of Thompson sampling, but as far as I understood, those limitations also apply to A/B testing.
Yeah, that's true.
Is there also a case where A/B testing is still better in some sense than Thompson sampling?
Yeah, so
Can you repeat the question, please? So it's a little important.
yeah, so the question was if in some case like A/B testing compared A/B testing to Thompson sampling, and the question was if A/B testing in some cases still was preferred to than Thompson sampling. And there are indeed some cases, especially if you want, like it is preferred if you actually want to know more specifically how each sort of variant is performing. You can imagine that for Thompson sampling you're putting less and less sort of effort in the lower performing variants, and if you do that, then you also have less knowledge about that specific variant as well. So if you want to have sort of equal knowledge about all three of the different variants, then it would be preferable to show all three of them equally in this case.
Given that this is PyData, can you maybe talk a bit about your Python toolbox that you use? For example, did you use PyData or
Yeah. So the question was if I could elaborate a little bit on the Python packages which are used. In this case, we used mostly NumPy packages. We have tried it as well with PyMC3, but because we wanted to more quickly incorporate this in calculate these kind of distributions, we needed to actually sort of manually sample these different hierarchies, because PyMC3 can be a little bit slow in some cases. I think it's a great package in general, but it can be a little bit slow, especially if you're adding more layers, sort of thing.
Where does the information for segmentation comes from? Is it provided by another company, or do you make it or extract it based on previous advertisements?
I can answer that.
Very good question.
So, is it on or not? Do you hear me? Okay, so the question was where the information comes from the segmentation. So in this case, the difference per client that we work for, in this case the client itself had it, and Kantar is a research agency that did it. So it's basically qualitative research, which they ask a large sample of current customers of this car manufacturer. They asked them about a lot of things. So first of all, age, gender, income, household status, where they live, etc. But they also asked them a lot of attitudinal questions towards what do they prefer when they buy a car, what do they value, what's important. So it's a combination of that. Then that qualitative research we also plotted on their actual sales data, and we managed to build those segments. Does that answer your question?
Yeah, yeah, yeah.
Okay.
That gives us a lot of
But it's a very good question, because I hope it was all clear from the talk, because obviously an algorithm is as good as what you put into it, and it starts with a certain assumption or hypothesis, and we base that on actually research, because if we didn't have to research, we made some random audiences up, there would have probably come something out of it, but you could question the relevancy of this case. So I think it's very good to start with that research.
Two small questions. First one, yeah. So, did you use online for the training? And the other one was, what was the most important, most predictive context for segment?
Good question. So the first question was if I used online training. I think you mean with online.
In the sense that you would get, let's say, like, yeah, you would suggest the content to the viewer, and based on the feedback online, you would train the algorithm.
No, that's we didn't use that specifically in this case. It's quite hard to, in general, already sort of get the information of a specific person, and secondly, it would take a lot of computational power as well to, like, for each variant, for each specific creative which you show, then calculate what the new probability would be. So we didn't use online. We updated like the model or the probabilities every day in this case, which was enough as well.
And the other question was, what was the most predictive context?
This question was, what is the most predictive context?
Was it not like in Nico the boot space, etc., versus the elderly people? I don't know if that was his question, but it's more like we noticed that, for example, for elderly people, in a very extreme example, we noticed that younger people valued a lot the way the design in the car looks, and elderly people. And this one dimension we look at, they were more involved for that specific model about whether they had like a car that they could step into easily, that could carry a lot of passengers' weight, and also the designs were also focusing on those USPs and showing the boot space of the car, whereas younger people are more associated with, okay, how do I look in it, how does the car look itself?
Yeah, perhaps a good one is this graph here, which I didn't come to, where you can see indeed they're like in the where people are a little bit lower age, you can see that distributions are quite close to each other, where for also 35 to 55 and 55 plus, there are more differences between the different variants as well.
To what extent do you track individuals' data in this system?
The good question. So, to what extent do we track individuals' data? We don't track individuals directly, as in we gather data mostly of if we've shown a certain variant to someone, and if what sort of if they clicked on it or not. Yeah, of course, for the different segmentations, it's mostly coming from the display platform itself. I honestly, personally, don't know exactly how they built that platform itself, but there probably is some tracking involved in there where you need to segment these people into different segments in this case itself.
Maybe the last question. Yeah.
So basically, the win is whether they clicked on the ad or not. That's how you know whether the win is.
Yeah, exactly.
So if you get all the data about what they like based on what they say, so what they fill in the survey and they're like, hey, I like this, this, and that, and then you evaluate how your segmentation works based on how they interact with the ads eventually.
Yeah, maybe to add to that, this was a first proof of concept as a final note. The client's KPI in this case was really to evaluate it and click through, to evaluate it and click through rate. I can imagine that people might argue, okay, for the marketeers here, it could be top funnel advertisement awareness kind of ads. Maybe you want to evaluate on a different KPI. We're looking into, for example, building this model on, for example, view time, that how long did people look at the ad. That data for this client was not available, so we worked with the KPIs that they gave to us. But yeah, that's, I think, a valid question.